Hello and welcome, everybody. Thanks for joining us. Welcome to the Virtual Science Cafe, brought to you by the North Carolina Museum of Natural Sciences. Glad that you could be here with me. My name is Chris Smith. I will be your host this Thursday night and just about every Thursday night for our Virtual Science Cafe series, where we find smart, interesting people doing smart, interesting things in the world of science, technology, engineering, mathematics, and even more. And well, normally we would bring them into our building in downtown Raleigh, put them up on stage, give them a microphone, and let us all learn the things that they're most passionate about. But right now, we've decided it's really good that we can do this using the internet. And so great because we can get folks on the internet that otherwise it might be a little bit difficult to get them to come to Raleigh, North Carolina, so that we could learn from them and get the chance to meet them. And of course, like always with our Science Cafe series, one of my favorite parts, and maybe yours too, watching wherever you are, is that you get the chance to dialogue and have conversation with our guest speakers too. So I'll remind everybody watching on YouTube, wherever you happen to be watching, use the chat box over there, because right there is where you can leave your thoughts, questions, comments as we go throughout the program. And then when we get to the end of the presentation part of tonight's show, I will moderate those questions and thoughts back to our guest speaker, and we'll create conversation, right? It's fun because we learn from them and then they get to hear what all of us are thinking about in terms of these topics too. So that's how the show is going to go. Again, so glad you could be here with us. If you haven't already, tweet the YouTube link out and tell everybody to come join you, because I think we're going to have a really great show. My guest tonight is Dr. Jim Carlton. He's Director Emeritus of the Maritime Studies Program at Williams College and Director, I believe, Emeritus of the Mystic Seaport Aquarium is what I read as well. Anyway, you may know Jim's work from the front page, the cover of Science Magazine back in 2017 with a report on, I think it was called Tsunami Transport. Already sounds interesting, right? Jim, welcome to the show.
Great, great to be here, Chris. Thank you very much for having me.
Yeah, glad that you could join us. Now, where exactly in the real world are you right now?
I'm zooming in from Mystic, Connecticut. It's a very pleasant fall evening here.
Oh, now a fall evening in Connecticut does have a nice sort of ring to it.
Very New England-like, yes.
Yes, very New England. Although I have to say, maybe my accent gives it away, but I've spent my life in the southeastern U.S. and we have nice fall evenings as well.
Absolutely. Yeah.
All right. Well, I'm taking a quick glance at the chat, and everybody is already excited for the program tonight. So I'll go ahead and turn it over to you.
Great. Thanks, Chris. Let me just get the PowerPoint going here. And off we go. Welcome again, everyone. A pleasure to be here tonight. And our story is going to be one that takes us back to 2011 and is now actually 9 years in progress and still going on. Many of you remember the massive earthquake and tsunami that hit Japan, northern Japan, north of Tokyo, largely on March 11, 2011. Wave heights were up to 133 feet and a mile or two inland. It remains the most powerful earthquake known to have hit Japan. Loss of life was tremendous. More than 18,000 were lost, often within minutes. It was an undersea earthquake set off the coast of Japan under the sea floor. And these are the kind of images that one saw soon after in the media to get a sense of the scale, the power, the force of the tsunami that moved ships inland, took out entire towns, and remains one of the great devastating events of the northern Honshu coast. The prediction for the tsunami form, the wave form, was accurate within minutes as it progressed across the entire Pacific. I happened to be in Oregon when it arrived on schedule per this model. It arrived in the Galapagos Islands also on Friday, March 11th because of the time zone. It was still March 11th on the other side in the Eastern Pacific and took out the Marine Lab. And that tsunami wave arrived all the way in Antarctica and loosened about 50 square miles of an ice shelf. So it was a basin-wide effect. What we know that was swept out to sea, entire towns, aquaculture, fisheries facilities, over 1,000 small boats, virtually everything you can imagine that was on a coastal zone, millions of objects were swept out to sea. That little green bucket I show there, the child's bucket, I was part of a ceremony in Japan that returned that bucket to the family that had lost that. Large ships, entire coastal forests. That material was engaged then by the gyre systems of the North Pacific Ocean. Complex, this is a simplified model. Uh, Debris went north and south, actually, along the coast with some coastal currents. Eventually, much of it was engaged broadly by the North Pacific Current and headed toward North America and turned back, in some cases, to the Central Pacific in the Hawaiian Islands. Now we're 1 year later, it is the spring of 2012, and a little ahead of most models, Japanese tsunami marine debris, JTMD, began to arrive in North America. A soccer ball from a high school showed up in Alaska, a Harley Davidson motorcycle in its crate, which is now in the Harley Davidson Museum in Milwaukee, and a large ship, the Rio Maru. This was a squid boat. It had been decommissioned and was moored in northern Honshu. It was first detected at sea off the Canadian coast, although no one noticed it drifting across the entire North Pacific Ocean for about a year. The Canadians were very thankful that it then drifted into US waters, into Alaska. The journey of the Rio Maru also became a musical piece for a bassoon quartet. The Coast Guard cutter Anacapa, which rarely has a chance to use its guns, took advantage of the drifting of the Rio Maru as a hazard to navigation, and with cannon fire, sank the boat in about 6,000 feet of water, a little under 200 miles off the Alaskan coast. Unfortunately, before we could get a good look at what was on the bottom of the boat, but whatever that was there likely sank most of it with the boat into deep water. I'm going to take you to the port of Misawa, which is a US Air Force base in northernmost Honshu below Hokkaido. This is what the port looks like on a quiet day with the 4 massive docks. These are used for fisheries purposes. Each dock weighs about 188 tons. Their life is about 500 years. They are absolutely massive. Concrete, steel, they're unsinkable, technically. They are filled with pre-stressed styrofoam. We know that under those docks were hundreds of species of animals and plants that make up the fouling or the biofouling community. And an arrow there points to the white rams. Keep an eye on those. I'm going to take you to March 12th, the day after the tsunami. The docks are gone. You can see the white ramps in place, and they've disappeared, washed away from the harbor. There are the 4 places where the docks were. What we know is that they weren't taken out by the tsunami wave that came in, but in the trough of the wave, when the harbor emptied, they fell off their anchoring points. Where did they go? They were gone. They went out to sea. We can't see them with the kind of satellites we have access to. They look like tiny human hairs. They're drifting around the ocean without lights, without GPS, nothing you'd want to run into on a small boat going 8 or 9 knots. It'd be going right into a brick wall. It's now June 5th, 2012, 14 and a half months later. Morning beach walkers report a large dock has appeared in Central Oregon, just a bit north of Newport. And here it is. And that dock had traveled 4,000 miles across the Pacific Ocean. How do we know that? How do we know where it came from? And fortunately, it had a sign on it saying, "I'm from Misawa." And it had been built in 2008, lost in 2011. Here's the scale. There's a truck and people next to it. And there it sat on the beach as it came ashore, where it was going to sit for a few months. Immediately, what was noticed is that there was a rich coating of animals and plants on the dock, the ark from Misawa. As it happens, it landed a few miles north of the Oregon State University Marine Science Center. Marine biologists arrived on the scene that morning, and we can see a rich coating here of mussels. Middleus gala provincialis, well-known invasive species, an invader of Japan from the Mediterranean, and a Japanese kelp, also a well-known invader, all together with sampling about 130 species of living invertebrates, seaweeds, some protozoans were on the dock. What caught immediate attention from management and policy purposes was that a number of the species had wanted posters on them from around the world. The sea star was a known invader in Australia. The seaweed was an invader in parts of the world, including California. The shore crab was an important invader of the New England coast. This therefore caught the attention of Oregon state officials very quickly. And within 24 hours, teams were deployed to start removing all the living things, if possible, on the dock. They were scraping the dock on the top and the sides, burning off what they could, and whatever was scraped was then buried on the high beach. The plastic bags were empty, and in it went. In retrospect, perhaps a little bit further up, but things were moving pretty fast. In August, remember it landed in June. In August, the dock was cut up into 4 massive sections and hauled off the beach. I visited that site and the dock in August, and we did find a few living species still on the dock that could have been reproducing in the bumpers, which had not been removed and not been inspected. What happened then over the next few months, the summer of 2012, the fall into 2013, waves of debris began arriving. Many boats, as you see here, upside down. Dynamically, they turned over. Buoys, large objects from facilities along the Japanese coast. We were able to, with cooperation from the science teams we put together, from beach rangers, from citizen scientists, and a lot of other folks, we were able to gather up 600 and some objects from Alaska to California and Hawaii, and examine the living species that were on these objects, of potentially thousands of objects that arrived with living Japanese species. Altogether, it was extremely diverse, the biota, really an amazing range of marine invertebrates, covering all the major phyla, a number of kinds of species that we did not associate with fouling on the bottoms of ships or even with ballast water in boats. And altogether, just under 400 living Japanese species that we cataloged and studied that had arrived between Alaska, California, and the Hawaiian Islands. This is the Saishu Maru. It is an Abalonian sea urchin boat. We were able to track down many of these boats by their registry numbers. You can see there the IT, standing for Iwate Prefecture, and then the number, with the help of the Japanese consulate, able to often locate the owners and talk with them about the boat. Many of them were just amazed that the boat had been found on the other side of the ocean. While most vessels, as you saw a few minutes ago, were upside down, the Saishu Maru managed to cross the ocean right side up. And in the stern well back there, which had been down at the stern, well, was more or less level with the water, a tide pool had formed with a rich algae community around it. And in that tide pool were Japanese fish, 5 of them. And these were all captured. 4 of them went on to their scientific immortality for museum collections, and 1 of them went into the Seaside Aquarium, small aquarium in Oregon, where it survived until 2016. This is the barred knife jaw. I don't have time to tell you the details of this interesting story as it developed over the next few years, but barred knifejaw then began to appear in Southern Oregon, in Monterey Bay, and all the way down to Malibu, all apparently transported by tsunami debris and having escaped some of that debris when it came ashore. Barred knifejaw had never been detected on the Pacific coast in the previous 150 years or so of studies on the fish fauna. I'm happy to talk about more details in the Q&A about everything we found and our interpretation of the importance of some of the rafting. But a question that came up for us early on is, how does this event, which was the largest event we know of in the history of marine biology, to track a debris field crossing an entire ocean basin, how does this differ from natural rafting, which has been going on, as far as we know, for a very long time? Historic rafting, natural rafting, as it were, basically wood-based. Pumice can be a little bit of it, perhaps, but wood has been thought to be the major vector historically in rafting. Trees, branches, root masses, with monsoons and typhoons and so on in the Pacific, the Indo-Pacific, perhaps even very large, almost island-like masses deployed to sea. What we found very interesting was that the wood that we could identify that had come from Japan, very distinctive, both building lumber and trees, which with forensics we could tell where it was from, pretty much disappeared in the first few years of the event. It turns out that wood was primarily consumed by shipworms, which are bivalve mollusks related to clams, marine invertebrates, and specifically, there are shipworms that live on the high seas in the open ocean that live just in driftwood in the mid-ocean. These are not the same shipworms that live in harbors and ports and bays. That wood was highly compromised. The last pieces of wood we found coming in after a couple of years was just dissolving in our hands. So the wood was biodeteriorated, sank, and pretty much disappeared. But the rafting went on from the debris, and that's because what persisted was the plastic and fiberglass plastic fraction. And the debris continued to arrive. We published our work in 2017. Debris with living Japanese species continued to come in 2018, 2019, and just this past spring in 2020, a vessel lost on March 11, 2020, landed on the Oregon coast with living Japanese species, all of which were brooders and basically self-replenishing on this floating plastic island for 9 years at sea. A remarkable insight for us about the ability of coastal species to survive for long term on the high seas. Without plastic, the tsunami phenomenon that we looked at would have ceased years ago. So this led us to consider the bigger picture, how an interaction between the history of plastic, coastal development, the movement of species, and in fact climate change could be interrelated. The history of plastic is a fairly young one, only since about the last half of the 20th century. That took us to a question as to when was the last major tsunami comparable to the 2011 event that we could look at for a history, prior history of potentially similar rafting. And that took us to 1933, an offshore event about the same location, which had impacted Aomori and Iwaki prefectures. But there were no plastics in 1933. Fiberglass comes on in 1936, styrofoam in the 1940s, and then nothing is really widely available until the 1950s or 1960s, when the plastic society, embedding plastic into how we live and what we do, becomes integral. Presumably, the 1933 tsunami then sent almost entirely wood into the North Pacific Ocean. We've searched broadly and deeply for any evidence of what might have washed ashore in North America and Hawaii from that event. We haven't found anything yet. We're still looking. It wouldn't be surprising if there were some boats that came ashore buried in some newspaper records, but we've looked at some of those too. That brings us then to how does that relate to the history of coastal urbanization? The concentration of what became mega cities on coastal margins. We only have to look at Miami as an example of that. Here's Miami Beach in 1925, Miami Beach 2017. And this type of comparison would be global, almost anywhere in the world. That suggested to us that what had happened in the last 50 to 60 years was a massive concentration of plastics at the land-sea interface without any historical precedent before the 1950s, well within the memory of a great many people, of course, still living. How did that relate to climate change? Well, we know from many models and observations in the last 10 to 20 years is that there appears to be an alteration of the frequency and size and the development of cyclonic storms, hurricanes, cyclones, and monsoons due to our human-mediated climate change. This would then suggest to us that this increased frequency of storms would novelly interact with our positioning these vast amounts of plastics at the land-sea interface and lead to unprecedented amounts of sweeping this material into the oceans to be colonized by marine life. Now, of course, we looked at a tsunami event, which is not climate related, but this bigger picture began to develop as we began to consider the system. For us, that took us to the probability that we would have to begin to think about how marine debris, plastics in the world's oceans might begin to change our understanding of dispersal of species, both along the coast, both transoceanically and potentially interoceanically, and how that might be changing the biogeography of species, altering diversity, and the potential for the invasion of species, which would have few or in fact no other vectors that might carry them such a long distance for so far to new continents. That's a very quick summary of what is now going on for 9 years of work. It's been absolutely fascinating. I've been studying invasions in the sea since the 1960s. I never thought that I would have the opportunity, nor did members of our team, to be able to study a major rafting event, or really any rafting event related to transoceanic dispersal. I've walked the beaches of the Pacific coast where we did this study for over 50 years, from Alaska to Southern California. I was always looking for something washing ashore that told me it had come from overseas, and had never found a single thing. Then commencing in 2012, the debris field arrived, and we're still studying it. So, Chris, over to you, and happy to have questions and discussion about this phenomenon.
Thank you very much. Interesting stuff. There's a lot to think about with this research. Just the way that it highlights the interconnectedness of the entire planet. So the Pacific Ocean is a big place.
Yeah.
And for even the smallest of plastic and fiberglass debris to cross that great expanse and make it to our own coasts is impressive. But then that all the things that live in the ocean find opportunity to live and reproduce on those things and travel with them, that blows my mind.
It's a phenomenon that again, as I said, we didn't have any prior opportunity to study, um, in part because while there's a lot of marine debris out there, a lot of it, we rarely know where it comes from or how long it's been at sea. But here was the first event in the history of marine biology, as far as we know, where the launch point was known, the launch date was known, and we had a very good way to track a lot of this stuff as it was crossing the ocean. Um, how long the phenomenon was going to last, we didn't have any idea. And by 2016, 2017, 2018, we thought maybe it was fading away. But now we know that there's still a lot of JTMD, Japanese tsunami marine debris, still out in the North Pacific Gyre, both Western and Eastern Pacific. A lot of it has very complex tracks. And those 4 docks from Misawa are a really good example of that. One of those Misawa docks arrived in the summer of 2012 in Oregon, and another one in September of 2012 made a hard right and turned and went past the Hawaiian Islands in September 2012 and went back to the Western Pacific. The third dock, wherever it had been, arrived in Washington in December 2012, about 6 months after the first dock, and the fourth dock has never been seen. Many of us have since that time been carrying our passports wherever we go in the world, just in case the red bat phone rings and someone finds the fourth dock.
Yeah, you're ready to go get that data.
Yeah.
Oh, wow. So you've been doing research on marine invasive species for much longer than just this one study.
Yes.
And never seen things that have crossed the entire Pacific to land. So in doing these other studies, the ones before this, what are you looking for in that case? Species from Alaska that wind up in Washington, Hawaii to California, and then how does that inform, this transoceanic movement?
Yeah. Certainly when one explores any coastline, you can find debris washing ashore, and often it has things on it. My not having found anything washing ashore from Asia and all of my marine biology colleagues, doesn't mean that it never happened. We quickly acknowledge that. We just think it must be extraordinarily rare. In the 150 years of literature of marine science, no one ever published a statement that anything from Asia had been found washing ashore with coastal Japanese species. Glass balls, glass fishing floats washing ashore all the time, but not with coastal species from Japan or other parts of Asia. And those glass balls had ocean living barnacles on them called lepus. We do know from the beachcomber records that a few things were found. And one of my primary sites was to start digging in beachcomber websites. Curiously enough, some of the most interesting objects had no date and no location, even though they were said to be found on the Pacific coast, because a lot of beachcombers like to keep their hot spots of debris secret. But we think it's happened before, but so rare, it's generally beyond detection. Debris moving along the coast, up and down the coast, absolutely. Again, surprisingly poorly studied as a transport vector for a great many species.
Interesting. So I'm going to turn to the chat for a couple of questions here.
Sure.
The first one up here, okay, is about the ship that came across. Why did they sink it rather than allowing it to be studied?
Yeah, that's a great question. Actually, there was a company that was interested in getting the ship as a derelict vessel, but then decided against it. It was just too much to deal with, and they abandoned that. And once the Coast Guard established that nobody was interested in claiming the ship under international law, they decided it was just a hazard of navigation. Things moved very quickly. Decisions were made within hours. We were not contacted as a as scientists to study what was on the ship. But at that time, admittedly, we did not have a research group established because remember that ship came in the early spring of 2012, and we got onto this project in June 2012. So I just don't think anybody was thinking about it. I got access to additional video taken by Coast Guardsmen on a Kappa, and we studied it as much as we could to see if any video revealed anything on the hull as the ship went back and forth, but it just wasn't a good enough resolution. But one imagines that maybe a few things were shook loose a little bit after they hit it with cannon fire, but basically we think it and its biological cargo probably went down to the deep sea. But it was an interesting opportunity that we did miss.
Well, so that brings up an interesting question for me then about how you were able to pull together all of the marine biologists, ecologists, this extraordinarily, must have been a large team working all up and down the West Coast to be out there collecting data and looking for debris and then collecting species, sorting. Gosh.
It was a challenge. We did establish a very good network with fish and game officers, state officials, county park rangers, citizen scientists, everyone you can imagine, and get the word out that we were interested in objects that came ashore that with living things on them. We got a lot of stuff that was not Japanese tsunami debris. Along the way, we found there were a lot of interesting stories. In the early days, 2012, 2013, a fair number of boats were coming in that people found, and they were in really good shape, and they wanted to take and take home. The often park rangers would stop them from doing that, and then we have no idea how much other stuff came in that really we think we didn't detect, broke apart as it arrived on the coast, especially on rocky shores. A great many of the objects we found, the majority of the objects we found or we were able to get our hands on or that were given to us, or we got photographs and then they collected the item for us, were on open sandy beaches. Of course, we don't know how much came ashore on rocky beaches because beach walkers and beachcombers and morning beach folks generally don't walk on the rocky shores. So that was one of the biases of what we were limited to getting. But yeah, it was a challenge. It worked very well in the first few years. After a few years went by, interest began to fade in the tsunami phenomenon. But we did have a couple of enduring people, and there are folks in Southern Oregon and in Washington who basically continued to look almost every day and find some really cool stuff.
I suppose if that fourth dock washes up, we'll know about it too.
Yeah, the third dock disappeared. The third dock drifted past Hawaii. It was found by a fishing boat. They kept it a secret for about 3 days. They took 5,000 pounds of mahi-mahi from around the dock, and it was acting as an FAD, a fish aggregating device. They turned over the video to a Hawaii TV station. I spoke with the captain and I spoke with crew members about what they saw on the dock. They said there was a lot of seaweed, but didn't have any other details to share. That dock was really looked for. It was found over the couple of days drifting past Molokai. A lot of people deployed in boats and helicopters to go find it because they wanted to get it and bring it in. But it just drifted away. Nobody ever saw it again, and it headed somewhere out to the Western Pacific. Models show that it could have gone out to Taiwan or even the Philippines, but it too has never been seen again.
Bronwyn on YouTube is asking, what was the most interesting thing you found?
Yeah, good question. We found a wide variety of invertebrates that we just do not find on the bottoms of ships, or that we had no record of being in ballast water. Several species of Japanese sea stars, alive and well, starfish. We found chitons, which are mollusks coming in on a certain type of debris. Didn't really understand that, but chitons came in on pieces of what were marina floats, docks that are disassociated of pontoons. really the surprise was the total diversity. We looked at it and studied almost everything we could, from nematodes and protozoans all the way to fish. And the challenge there often was taxonomy. And I'll just mention quickly that we took about 80 taxonomists from 12 countries to help identify what was on the JTMD. And the scale of the resolution often was pretty good. We collected little tiny mites, and mites that we found. These are 500 microns to a millimeter in size, and one of them from the mite people turned out to be a gull mite that had fallen off a seagull that was then eating the stuff on the beach,
Oh
on the
my
debris
gosh.
after it landed. That to me was a nice example of our ability to use fine scale taxonomy to sort out what was on the debris. Good diversity of living mollusks, a wide diversity of crustaceans, mobile and attached. What we did not find were, and several botanists have asked about this, whether or not we found any plants that had rooted onto some of the larger debris and came over. We did find trees, Japanese trees, that came over, and that was fascinating. One of them had large rocks in the root mass, and on those rocks, marine invertebrates had settled after the tree had been tossed into the ocean.
I guess life finds a way.
Sorry, was that?
I said, I guess you just say life finds a way.
Yes, life finds a way. Absolutely. Yes, yes, yes.
Okay, Cindy's asking, is climate change, which is causing ocean temperatures to rise, causing changes in the pattern or number of gyres?
Yeah, that's a good question. I'm not a physical oceanographer, but my understanding is that yes, there is the potential for that. I don't know the extent to which it has been documented yet, but we have major oceanographic phenomena that are clearly shifting. Huge warm blobs, which are without precedent in the North Pacific Ocean, possibly linked to climate change, detected some shifts in current regimes at a smaller scale, not yet changing the Kuroshio or the Gulf Stream, as far as I know. But I think the potential is certainly there in models. It's a scale question, whether that's going to be a finer scale or a larger scale question. And if that's the case, and if there is change at a larger scale, the behavior of the gyres and their accumulation of plastic debris would be on the radar for us.
Well, so, okay, that brings up something interesting for me because I'm thinking about like plant and animal community succession on these things. And if you're seeing a lot of Japanese species on docks and other debris, is colonization of these things happening very quickly and then they're sailing across the ocean, or are they building up these enormous communities, year after year?
Yeah, we don't know very much about the details of that. It's fairly clear that when a lot of the debris entered the water in March 2011, it was colonized. That has a lot to do with the residence time of that debris in coastal Japanese waters, whether it was captured on inshore currents and held in a boundary current before it went out to sea, and the ability and how long that material had to be colonized by coastal Japanese species before they left the coastal zone and headed out to the wide ocean. We do know that some of that debris moved south, despite the larger picture of the currents. Some of the debris moved south to southern Japan into the South China Sea before being re-engaged and coming back out to going north and then east again. We know that by biological forensics, because as the debris left northern Japan, southern Japanese species settled on top of the species from the earthquake area. And so there was an accumulation. The community did build up. Once you're at sea, colonization can proceed with oceanic species that live on the high seas, and that happened as well. What's interesting is that when that debris arrived on the Pacific coast or in Hawaii, residency time in Hawaiian or or eastern Pacific coastal waters appears to have been very low, because the only species we found from Hawaii or from California, Oregon, or Washington, for example, that were from the North American continent were just juveniles, 1 and 2 millimeters, suggesting that after arrival, they came ashore pretty quickly, that material.
Interesting. Thank you. All right, let's see. Another question from the chat. Did any of the invasive species from Japan take hold in the new ecosystems where they turned up?
Yeah, a really good question. And the answer is we were not sure. It's been 9 years now. Biofoul debris with living species began arriving in 2012, 8 years ago. We have the living barred knifejaw, one of which was still seen in 2019, swimming around in Monterey Harbor. It had grown from 6 inches to about 18 inches. As far as we know, there was no reproduction. There's a sea anemone that we're very curious about that showed up in Southern California that we're trying to now look at, which by photographs looks identical to the one that we had on some of the Japanese debris. But in general, we don't have a good picture of that just yet for a couple of reasons. One is there's often a lag time of some years between the arrival and inoculation of a species, and it's building up populations for our being able to detect it. So if there are incipient populations growing in some parts along the coast, they may be still below our radar. Another reason is it's extraordinarily hard to get survey money. So just to go out and look for species on a general survey basis, generally something relatively hard to get funding for, and thus we rely on citizen scientists, very local studies, in case something new shows up that people who've been at a particular site for years say they've never seen before. So it's likely that far more than the 380 species arrived. Remember, we sampled 600 some items, thousands of items, perhaps tens of thousands of items arrived. The diversity actually was higher. We can look at that in a model, what are called rarefaction curves. And I would fully expect that some of those species would become established. Let me mention a third thing, however, before we leave that question, which is that many of these species were small types of invertebrates that are often not well studied. Bryozoans, small crustaceans, sponges. And so if some members of those types of taxa were to become established, there's a pretty good probability that they would not be noticed and they would not be identified in a reasonable amount of time. So, however, we keep our eyes out and suspect that we will be getting some records as the years go by.
Long-term projects there.
Yes, indeed. Yeah.
So many more resources and graduate students.
Citizen scientists will be
yeah,
the
citizen science.
Absolutely, it'll be absolutely key in this type of work.
Yeah, it's everybody get your iNaturalist out and and head to the West Coast.
Absolutely.
All right, let me take a look what's happening over here in the chat. Okay, I need to just give some shout outs. We have viewers from the Atlantic coast of Patagonia and Argentina who have tuned in. So thanks for joining us. They're very excited to hear you talk, Jim. They said so themselves. And then, of course, Megan McCullough and team aboard the RVIB Nathaniel B. Palmer about to head to Antarctica on an invertebrate survey and research crews.
Excellent.
Are tuning in from the conference room aboard the ship.
Excellent. Hello, everybody out there at Port Hueneme.
All right, now James has got a good question here. How could a software engineer volunteer to help you and your group of scientists work more effectively? Are there other tools that could make this project sing?
Yeah, thank you. That's a great question. More and more tools are being developed for online accessibility for identification of species, for recording species. And I think the sophistication of that software, we're just at the beginning of what we can do in terms of capturing real-time photographs, still photographs, videos out in the world, getting it online. iNaturalist is a great platform for that kind of stuff. But I'm sure that even that type of software could be developed and really expanded rather elegantly. So I'm a big champion of what software can do to link science and the public and the press, the media as well, to capture what's happening on a regular basis on the coastal in coastal systems, on the coastal ocean. The eyes and ears of the public, including software folks, are how we know about what's going on in the ocean. Most of you who are listening to this know that you can go to the beach, go to the coast, and you will never ever meet a scientist. And so the people whose eyes and ears and understanding of the coast are those who are out there watching the ocean for us, applying their knowledge, their technology to trying to capture good data and get it back to scientists to understand the pulse of change along the coastal seas.
Excellent stuff. Excellent. Thanks, James. That was a great question. All right. Megan is asking, has any of the debris circled back to Japan from the US with invasive species from North America?
Yeah, good question. We don't know that yet. We do know that a boat that was lost in the tsunami, by the timing of its discovery, went all the way around the Pacific Ocean and returned and landed in Okinawa. I was very interested in what was on that boat. However, by the time we sent a team down there, Japanese colleagues, to get to that boat, it had been cleaned off. So we don't really know what was on the boat. We don't know how much debris gets so close to the Pacific coast of North America or to the Hawaiian Islands that they would capture species from North America or Hawaii and then continue on their way. Presumably one would have to get within 50 miles or so to really get into some of the larval streams and larval clouds of coastal species from North America, for example, but not be captured by the current systems and the onshore movement and escape that to continue on. We don't have a picture of that just yet, but certainly to me, that would not be an impossible scenario.
That almost reminds me of a study that was published just a few weeks ago about finding plastic debris at the bottom of the Arctic because of these just massive currents moving things all over the planet.
Yeah, debris has been going down to the deep sea around the world for decades. And so some of the early discoveries of some of the first photographs that were coming back from fairly great depths, we were seeing a disturbing amount of stuff that had sunk down there and been preserved on the deep sea beds, deep sea floor.
Hank and Denise are asking if any debris has been detected outside the Pacific.
Not that we know of. And hello, Hank and Denise. Nothing in the South Pacific either. So just North Pacific so far. If things got down to the South Pacific, it may be that they were not recognized as Japanese debris from the tsunami of March 2011. We do know that objects lost in the North Pacific can cross the Arctic and show up in the North Atlantic. And we know that from the loss of rubber duckies and some other objects from container ships that apparently did cross the Arctic and land in New England. But it might also be that some of our objects, by the time they made that trip, simply were not recognized for what they were. The easiest recognition of Japanese tsunami debris were the boats, which had many of which had registry numbers. It told us the prefecture and it told us the owner, and then could be tracked back to that one date. Other objects, we used a variety of methods to determine that they were from the Japanese tsunami of that date, including the biology and the taxonomy of the species on that object. So given the massive scale of this event, it could have dispersed objects much more widely, and they simply were not recognized for what they were. But that's a great question.
Yeah, and I think you've alluded to this point a few times now during the Q&A, is that, you know, the amount of the debris is underestimated. The amount of species is probably underestimated. And then how far some of these things may actually end up traveling is still underestimated, which means that the issues associated with them, like an ocean full of plastic and debris and an invasive species traveling around the globe, is probably underestimated, right? And that we would need even more aggressive measures to try to mitigate that and do something about it.
Marine debris has been an increasing field of study now for a few decades, and it's really, really caught on in the last 20 years. So marine debris has been the subject and remains the subject of major international conferences. Assessing marine debris, the amount, the volume, the source, the fate, there are dozens or scores of papers coming out weekly. But just now, are we getting on to the question of what's on the debris? So we have a massive amount of tracking of debris, really great interest in trying to stop the flow, the continental supply pathway of debris into the ocean, understanding how we remove it from the ocean. But I think a really missed opportunity at a global scale is to try to really understand what this debris is carrying with them. And in a fascinating way, what's on a debris object biologically can tell us where that object has been and tell us a lot of the story of where debris goes and what its potential is to cross the ocean or go between oceans. But I'm hoping that more of the biology and ecology can now be infused into the science of marine debris, because of the huge opportunity of what, unfortunately, the massive amount of stuff out there, and we can get more people collecting and asking the questions. That's where iNaturalist would come in, better software to capture in real time what's on that debris and get it out onto the web. So I think there's real potential there, and very important to keep track of.
All right. There's a couple other questions here. We've got a couple minutes left in our time, so I'll throw them out. Because you're talking about biology, and this question is related to that. John is asking, for invasive species, do any of them adapt to the plastics or metals they travel on, or do those things end up not being good homes? He writes, or is plastic and metal toxic to them?
Yeah, both good questions. The adaptation to this debris field, and those questions have been coming up and on our radar for several years now. Are there population shifts? Are there even genetic shifts among populations that have been at sea for many years of certain species? Is there an increasing tolerance to certain types of substrate in terms of, excuse me, in terms of what's diffusing off the plastics? We know very little about that. So those are good questions. We don't know whether or not that that with tens or hundreds of millions of plastic items floating around the seas of the world, whether or not there is a good potential for exactly that, whether or not some coastal species could become adapted to what is essentially a novel habitat. So Good question. Lots of potential research there.
Lots of areas for growth. All right. Well, we'll leave it there. We'll let it float on. And
thank you so much for the opportunity. It's been great tonight.
Jim, thank you. This has been a fantastic conversation. People in the chat are over here saying that they enjoyed it too. So, so much applause for you. And thanks for joining us from Connecticut.
Thank you for all the people from around the world who and the time's pretty late in some parts of the world for coming aboard. And this story will continue, so we'll see where it goes. Thank you very much.
All right, everybody, take care. Hey, Megan and team out there on the research boat, y'all take care. Stay safe on your research vessel. For everybody else who's not using research vessel Wi-Fi, I'll remind you that you can follow the Museum of Natural Sciences on Facebook, Twitter, and Instagram. We're at Natural Sciences on all three. And you can visit naturalsciences.org to see the calendar of virtual events that are coming up, like next week's Science Cafe talk. We'll be talking with Steve Briggs from North Carolina State University about how NC State is working to feed the world through their new plant sciences initiative. So set your clocks, set your calendars right here, 7 p.m. Eastern at the museum's YouTube channel. Of course, you can subscribe and click the bell to get notified, and then you'll be there. You'll be ready to learn something new and have more interesting conversations. So everybody, take care out there. Stay safe. And I hope we'll see you again real soon right here on the internet. Bye, everybody.